In question 6, you need to use this solved equation you found in part 4, plugging in the solution from part 3 to see if you got the same answer as part 5. Since that's a lot of parts to remember what we were doing, let me write them down for you. In part 4, we found the equation negative f of x1 divided by f prime of x1 plus x1 equals x. In part 3, we found the solution x equals 4, and we want to plug this into our iterative function. Now remember, x1 was technically 1, and we found x equals 4, but we're going to now update and let x1 be 4 and find our new x. And our goal with that is to see if it equals the solution that we found in part 5. So plugging in, we end up getting negative f of 4 divided by f prime of 4 plus 4 should be equal to our value of x. Recall that f of 4 was equal to 9 and that f prime of 4 was equal to 8. But this needs to be negative because of the negative that we have on our equation here, and then we add 4 to this. So if you take 4 plus negative 9/8 in your calculator, you'll end up getting a solution of 2.875. And that is the solution that we found in part 5. Question 7 is asking us what's happening to the x values each time we run it through this process. What's happening is the x values are getting closer to the value that we found in part 1. So that means that they are then again related to that number that we found in part 1. How close are they? Well, if we take the square root of 7 and we subtract off our most current iteration of 2.875, we get a solution that's approximately 0.2292. Now, this isn't super close to the square root of 7, but it is getting closer and closer. And what your calculator does is it looks at this difference between the two numbers that we're looking for and sees how close it's getting. Now, technically, it doesn't know what the square root of 7 is. That's what we're trying to estimate. So really what it does is it looks at the difference between two iterations and sees how close they are. When two iterations are close, the calculator knows that it's done iterating. If they're still pretty far away from each other, then we know that it's not quite done. Lastly, we want to come up with the recursive formula that describes xn plus 1 if we know the xnth value. So if we know the nth iteration value of our process, we want to be able to go through and find the next iteration. Now recall that the formula that we found before was the form negative x1, f of x1, divided by f prime of x1 plus x1 is equal to x. Now x1 is technically that first value that's given to you, and then x is the next number in line. So what we can do is we can generalize this to be a different formula, where instead of looking at the first x value and then the second, technically, what this is, we can make this, say, negative f of x n, meaning our nth iteration, divided by f prime of xn plus xn is equal to xn plus 1. And we can then use that for any of our iterations to find solutions.